Hey TechnoStuds, now let's start looking at networking equipment and seeing what some of the vulnerabilities are with different protocols and some networking devices. In this video, we're going to talk about password attacks, we're going to talk about denial of service and distributed denial of service, we're going to get into some malware, we'll talk about ransomware, we'll talk about eavesdropping, trust exploits, on-path attacks, spoofing, compromised key attack, de-authentication, VLAN hopping, and port redirection. One of the most common types of attacks there are is against passwords, and that's because there's a lot of bad passwords out there, or passwords that never were changed, or just lacking passwords altogether. So it's something I'll just briefly mention here, but I'm going to go more in depth into good password and good password management in a future video. First up is denial of service. The idea behind denial of service is that you're doing something to a service that brings it down, hence the denial part. So an example is, let's say we have a server right here and it's running some sort of service. Maybe it's a web browser, or maybe it's something else. And this computer right here is going to try to attack it. It's going to leverage maybe some sort of protocol inefficiency, or just flat out just send enough traffic to this device right here that this device gets overwhelmed and then can't send out traffic to anyone else. Essentially what this is doing is it's affecting the availability of the service or the server. And so this could be as simple as this computer is sending out too many pings to this computer right here and flooding this with all of these ping requests, and now it's not able to serve out the services to anyone else. And the problem is that this type of attack is actually very simple to send and to get going. It's very easy to implement, and it will bring the system down, and it's hard to mitigate against it. So it's difficult to eliminate this issue. And so this is one that when people are just starting out, they're hacking and experimenting around, this is one of the common ones that they'll start out with. So another one that we will see is the DDoS, or denial of service, or the extra D is distributed denial of service. It's the same concept as before, but the idea is that you have multiple machines that are sending out and overwhelming this one machine. And this is a little more likely because sometimes it's hard for one machine to send enough traffic to a web server to overwhelm it. But if you had, it wouldn't take very many that were sending the same requests to this machine, and it would cause this server to go down. And one way that this could be leveraged is this might be owned by all one person, but sometimes hackers will go and hack systems or distribute some sort of malware that goes onto all the machines, and then we'll launch code. So between botnets and between command and control, we'll then notify everyone that, hey, it's time to launch this attack, and this is who I want you to launch the attack against, and it will launch the attack and bring the system down. So it essentially builds a bunch of zombie hosts that are out here that are going to do the attack, and then instructs them at the same time to do the attack, to do a distributed denial of service attack. Then we have malware. So malware is different type of programs that are distributed and then cause all sorts of problems. So an example of this is the virus. The virus starts replicating itself and starts infecting different machines and just gets passed from machine to machine. And ultimately what it's trying to do is maybe it's trying to alter some sort of code or corrupt some sort of data or just delete files altogether. It can cause computer booting issues. It can capture sensitive information and then send it to whoever created the virus. It can access and use email accounts. So it can do a lot of different things, but essentially, or it could even lie dormant, and then once it is called by something, then it becomes alive. And so this malware, a virus, can be pretty tricky, and that's one reason why you have to be scanning your computer for any kind of malware that might be installed on it. Another type is this worm, and a worm's job is just to replicate itself. Where a virus might be installed into some sort of other code and get installed in another code, a worm is just, its job is to replicate itself and just keep and stand alone and not necessarily inject itself into other software, but just keep replicating itself. And it can fill up drives and bring systems down because it replicates itself so much. Then we have the Trojan horse. The Trojan horse is similar to the old story about the army being in the Trojan horse, and they got behind the gates and then stormed the city and took over the city. Well, that's the idea behind this. And the idea is that it's a piece of software that looks legitimate on the outside. Maybe it is you're signing into some sort of service like maybe Office 365 or Gmail, and it looks like you're signing into that service, but in fact, you're signing into this other software. And that software is then taking your credentials and then shipping it out and sending it to somebody. So that way now they have your Gmail account or your Office 365 account or whatever it's designed to look like. So that's the Trojan horse. It's designed to look like something legitimate when it in fact is not legitimate. Now, in one of my other videos, I talked about the importance of encrypting your drive, but this is not the way we want to do it, and that is with ransomware. The idea behind ransomware is it will encrypt your drive on your machine, and so now you don't have access to your information, and they're holding it hostage, and they won't give you the key to unencrypt it until you pay them a certain amount of money. So the problem with this also is it's not just your machine that is at risk, but if it is connected, like let's say this machine right here is remoted in and connected into a file server over here and has access to all of these files and can write access to those files, and this computer gets infected with ransomware, it could encrypt this data as well, causing all sorts of problems to not just this one user, but to other users as well. One of the reasons why we want the least privilege, you need to have the least amount of access to whatever devices that you can possibly can, or whatever resources you possibly can, so this stuff can't get leveraged like this. But yeah, ransomware can be especially dangerous, and the solution for this is really to back up your systems and make sure you have a backup copy of your systems. Another thing hackers will use is trust exploitation. So let's say in this example, I have a network right here, and let's say this machine trusts this machine right here. So this server right here trusts this machine right here. But perhaps it doesn't trust anything outside its network right there. But this machine, even though it doesn't have access to this server, it does have access to this machine right here. And so what this machine can do is jump onto this machine, and then now it has access to this server because the server trusts this machine right here. On a very similar note, we have port redirection. In fact, this is a type of trust exploitation. And in my last example is this machine right here had trusted this computer right here. So in this example right here with port redirection, let's say this machine has RDP access to this machine. And so it does a remote desktop protocol into this machine. And so this is on port 3389. And now it has remote control over this machine, and then it uses the SSH program to SSH into here. And that is on port 22. So it's redirecting from port 3389 to port 22 to get onto this machine right here. Sometimes attackers will use this on path. And so they will insert a piece of equipment on the path in between one device and another, so that it can capture data, or it can do some sort of like changing of the data. And I'll give you an example of that. But it used to be called man in the middle. So most of the time you'll see this called man in the middle attack, but you also will see this now called this on path. So anyways, we have a machine right here, and maybe it wants to access this web server right here. Maybe it's even a banking software. Maybe this is banking software. And so the idea behind on path or man in the middle is you set up a piece of equipment, and instead of this request going all the way out to the server over here, that request then gets captured and sent to this device right here. And this device may go and grab the information. Remember, this is maybe the bank information, and bring back the web page, but make a couple alterations to it. So rather than the data going to this device right here, then the data is going to stay local here. Maybe it's grabbing a username and password. Maybe it's grabbing account balances. Maybe it's just listening and seeing what's going on. Maybe it's trying to trick the end user into entering personal information, and once again, bank account information, and maybe trying to steal money out of the bank account. So that's the on-path or man in the middle. One way to initiate this on-path or the man in the middle is using a rogue DHCP server. So an example of this is maybe this network has a DHCP server already on it, but I install my own DHCP server onto this network. And then what happens is when this machine makes a request for an IP address, this machine gives it an IP address that can work on this network, but also says, I am your router, so everything goes through me, or I am your DNS server, so everything goes through me, or I am, it could really specify anything through this since it's getting all of its information from the DHCP server. So it could really control what this device is using. So it could say, I'm your router, send all traffic to me, and then it, once again, similar, like I say, a man-in-the-middle attack, it goes out there and then finds the data and presents it back. Now it can be listening to all the traffic and figure out what's going on, listen to passwords and see what the username and passwords of these different sites, maybe present the user with some different information to leverage this rogue DHCP server to hack these systems here. Then we have a rogue access point. So what I've seen this before too, where somebody doesn't like the access points that the company has, and so they'll plug in their own access point into the network, and then they will use that access point instead to connect into. So the problem with this is that this rogue access point is not necessarily have the same security as you want on your networks, and it can cause all sorts of problems. So now maybe they have something like WEP, which is considered insecure, that's operating on the network. Anybody can break this and connect into this, and now they have access to the whole network, and the whole network is compromised. So rogue access point can be pretty devastating to your network. An evil twin does have to do with access points, but it's a little different. So now in a evil twin scenario, I'm going to set up a network in my own access point. So this access point is going to then pretend like it's part of this network, hoping that clients will connect to it instead. And now you can perform this man-in-the-middle attack again, or this on-path attack, because all the traffic is going through this other network that you didn't realize what it was connecting to. So an evil twin is trying to mimic whatever the real network access point is supposed to be, trying to mimic that so that way it can trick clients into accessing it instead. You see this a lot like at coffee shops, where they'll have rogue access points at coffee shops, or excuse me, evil twin access points at coffee shops, and it will look like the coffee shop access point, but in fact it is something illegitimate. Spoofing happens when some device pretends to be another device. So let's say we have a server right here, and this machine is trying to connect to this server, but somehow this machine is spoofing or pretending to be this server. And there are several different ways that this device might go about doing that, pretending to be this device right here. So if this server has an IP address of 192.168.0.5, and this computer right here sends out an ARP request for trying to find out the MAC address of this server, this IP address right here, then this machine may reply back and say, oh, that belongs to me, and here is my MAC address. And once this machine learns of that MAC address, it might have a hard time disassociating with that MAC address, thinking that it's communicating to this server when in fact it's communicating to this device over there. And so that's ARP spoofing. MAC spoofing has a similar effect, but it goes about it a little differently. And let's say this device right here has some sort of MAC address on it, and this device mimics that MAC address. What's going to happen is, as it sends out messages, this switch is going to think that that MAC address is on a different port and start sending traffic to this device rather than this device. So that is going to be a problem with MAC spoofing, and then therefore anything that's going and heading towards this server will now be redirected towards this computer right here. IP spoofing can also have a similar effect, but once again, in a little different manner. So let's say this address right here to the server is 192.168.0.5, and then it is also set on this laptop right here, and now some of the traffic that's supposed to be destined for this server right here would then get sent to this laptop right here, and that's IP spoofing. DHCP spoofing is a device on your network that is spoofing as a DHCP server. It's pretending to be a DHCP server. So really similar to what a rogue DHCP server is. So if you set up a separate rogue DHCP server that's responding, that's kind of the same concept of this. It's a device that when a message, a DHCP request is being sent out, it gets broadcasted out all the directions, and then this device then responds back with, okay, here's an IP address for you. Also use this DNS. Also use this router. And now it has control over its networking traffic, and so maybe it set up this device as being the router, so everything is now going to go to this device rather than to the actual router on the network. So that's DHCP spoofing, a device that pretends that it is, or it responds back to the DHCP requests and hands out these IP addresses even though it's not authorized to do so. With IP version 6, we have the router solicitation and router advertisement. So if this machine is sending out a router solicitation and then that router responds back with a router advertisement, it gives this machine necessary information on how to get out to the outside world. But if a router was on this network, or if a router, maybe this device right here is pretending to be a router, then it could send out its router advertisement to this machine right here. And then this machine might then start sending traffic to this device rather than the actual router. So that's router spoofing, is when a device pretends to be a router by responding to router advertisements. Then we have DNS poisoning or DNS spoofing. So the idea behind this is maybe this machine is trying to access a resource on the internet, and that is attached to some sort of domain name. So it needs to do a DNS resolution. So it asks its DNS server, let's say the DNS server is right there, and then somewhere along the way that this DNS response gets altered to a different IP address. It's not the IP address of the resource that's out there on the internet, but maybe it's even this local address right here. So the DNS record that comes back now is of this machine right here, and this machine starts redirecting traffic to the wrong location. The key to this is that the DNS response has been altered, and now it is pointing to the wrong resource, and it's not getting to where it needs to go. Generally, what happens when you are encrypting traffic between two devices is you're using keys. And there's a few different keys that you actually use through this process. But for this purpose right here, what we're going to say is this computer right here is trying to talk to this server right here. It's trying to create a secure connection, and it's using keys to do that. It first of all uses the private key that this server has on the machine to help encrypt the traffic that's going between these two devices. And so it'll use this private key to help with that process. And maybe what happens is it will use that private key to establish this communication, but then what it will do is it will create a session key that it will utilize for this direct communication back and forth. So what a compromised key it will be is if this private key were to be compromised, that would be really bad. Or if the session key were to be compromised, then any traffic that's going back and forth between these two devices can be seen and unencrypted. So whoever is seeing this traffic go back and forth can be able to read that traffic with this private key and session key, or insert themselves within this communication and do like a man-in-the-middle attack. So this is the compromised key, when a private key or a session key is compromised, and now that traffic is no longer secure. A de-authentication attack is when a device is talking to a wireless access point. So these two devices are talking. And then there's another device that will send a de-authentication signal back to this wireless, say, I want to disconnect. And then it will disconnect this connection. This laptop is no longer connected to this access point. So it's a type of denial of service because now this computer doesn't have access to this network. In one of my prior videos, we talked about segmenting your networks for security purposes, splitting up the traffic on your different for your different operations, your different departments, so that way sales has access to their resources, operations have access to their resources, and administration has access to the resources. One way we can do this is through VLANs, and we can create VLANs. But what can happen is this thing called VLAN hopping. And a VLAN hopping allows maybe sales to get somewhere into operations, or operations somewhere into administration, and vice versa. So this is what VLAN hopping is concerned, and it's a weakness in one of the protocols and one of the technologies that are used. We talked about a lot of different network vulnerabilities, common network vulnerabilities. So it included things like password attacks, denial of service, distributed denial of service, malware, ransomware, trust exploits, on-path attacks, spoofing, compromised key attacks, de-authentication, VLAN hopping, port redirection, and a few more. And so there's a lot of different ways that hackers can hack your network or take advantage of weaknesses within technologies and weaknesses within protocols. So this is all important to keep in mind as you're building out your networks. And there's different ways to mitigate these issues to either eliminate them or lessen the impact they have on your networks. But the most important thing is you make sure that you take a conscious effort to understand what your network is doing and understand what the weaknesses are, and figuring out what your risks are and start compensating for those risks, start mitigating those risks. Hope you're enjoying the videos. If you like them, could you hit that like button?